The scariest thing happening right now isn't a hurricane. It isn't a massive earthquake. It's the Pacific Ocean, quietly storing an incredible amount of heat, month after month, far below the surface, where almost nobody notices it. And now, that hidden heat is starting to move. That's exactly why more and more scientists are talking about something they rarely say lightly, possible Super El Niño. So why are they so concerned this time? What's different from all the El Niño events we've seen before? And if this really grows into one of the strongest events in modern history, what could it mean for weather, food, economies, and everyday life around the world? These aren't just questions for scientists anymore. They could affect every one of us, whether it's through higher food prices, stronger storms, longer heat waves, or droughts in places that have never experienced them before. In this video, we're going to break it all down in plain English. We'll look at what's happening beneath the Pacific, why experts are paying such close attention, what the latest data is showing, and what could happen if this powerful climate pattern continues to build. Let's get into it. Before we talk about why scientists are worried about 2026, we need to understand what El Niño actually is. You've probably heard the name before, but a lot of people don't really know what it means or why it matters. It all starts in the tropical Pacific Ocean. Under normal conditions, steady trade winds blow from east to west. Those winds push warm surface water toward Asia and Australia. As that warm water moves away from the coast of South America, colder water rises from deep below the ocean. That process is called upwelling, and it's incredibly important because it helps keep the Pacific Ocean in balance. When everything is working the way it should, scientists call it ENSO neutral. Think of it as the Pacific's normal setting. The ocean and the atmosphere are working together, and neither side is pushing too hard in one direction. But that balance doesn't last forever. Sometimes those trade winds begin to weaken. They don't push as much warm water west anymore, so that heat starts spreading back across the central and eastern Pacific. Sea surface temperatures climb above normal, and once they stay high enough for long enough, we officially have an El Niño. That extra warmth doesn't just stay in the ocean. It changes where storms form, shifts jet streams, and can completely reshape weather patterns around the world. Some places get much wetter than usual. Others end up dealing with drought, dangerous heat, or failed rainy seasons. One change in the Pacific can affect weather thousands of miles away. Then there's the opposite phase, called La Niña. During La Niña, the trade winds become stronger than normal. They push even more warm water toward the western Pacific, while even colder water rises near South America. The eastern Pacific becomes cooler than average, and global weather shifts in a different direction. Regions that were dry during El Niño may suddenly become much wetter, while others experience the opposite. These three phases ENSO neutral, El Niño and La Niña make up what's known as the El Niño Southern Oscillation, or ENSO. It's a natural climate cycle that has been happening for thousands of years. Most of the time, it switches between these phases every 2 to 7 years. So El Niño itself isn't unusual. It's part of how Earth's climate naturally works. What has scientists paying close attention today isn't the existence of El Niño, it's the fact that the Pacific Ocean is entering this cycle with far more heat already stored beneath the surface than we've seen in many previous years. And that's what makes this situation feel very different. Right now, the biggest story isn't happening on the surface of the Pacific Ocean. It's happening hundreds of feet below it. For months, scientists have been watching something unusual. A huge amount of heat has been building beneath the ocean's surface. You can't see it from a satellite photo or from a ship crossing the water. But the instruments below the surface are telling a very different story. That hidden heat is growing. And that's exactly what has experts paying attention. One of the biggest warning signs is something called a Kelvin wave. It sounds complicated, but the idea is actually pretty simple. Think of it as a massive pulse of warm water moving slowly across the Pacific from west to east. It can travel thousands of miles beneath the surface, carrying an enormous amount of heat with it. When that warm water finally reaches the eastern Pacific near South America, it begins pushing heat toward the surface. That's often one of the first major steps in the development of an El Niño. And that's not the only thing happening. Scientists have also been tracking unusual bursts of westerly winds. Normally, The trade winds blow from east to west, helping keep warm water piled up near Asia and Australia. But every now and then, those winds weaken or even reverse for a while. When that happens, it's like opening a gate. The warm water that had been held back starts moving east. Those wind bursts can also strengthen the Kelvin waves, adding even more heat to the system. By themselves, none of these signs automatically guarantee a major El Niño. But when they all start happening at the same time, scientists pay very close attention. That's exactly what they're seeing in 2026. The Pacific isn't just warming at the surface. Heat has been building below the surface for months. Kelvin waves are carrying that energy across the ocean. Unusual wind patterns are helping move it even faster. These are the same kinds of signals that showed up before some of the strongest El Niño events in modern history. That's why this isn't being treated like an ordinary climate cycle. No one can say with complete certainty how strong this event will become. Weather and climate are always changing, but when so many warning signs appear together, it's hard to ignore them. For many climate scientists, the real concern isn't what we can already see. It's the massive amount of energy that still hasn't fully reached the surface. Once it does, conditions across the Pacific could change very quickly, and that's the moment everyone is watching. At this point, you might be wondering, what exactly is a Super El Niño? Is it an official scientific term? Not really. Scientists don't actually use the phrase Super El Niño as an official classification. It's more of a nickname people use when an El Niño becomes exceptionally strong. The real measurement comes from NOAA, and it's based on something called the Oceanic Niño Index, or ONI. The ONI tracks how much warmer the sea surface is across a large part of the tropical Pacific compared to normal. If temperatures stay at least 0.5 degrees Celsius above average for several months, it's officially considered an El Niño. The higher that number climbs, the stronger the event becomes. Once it reaches around 1.5 to 2 degrees above normal, it's considered a strong El Niño. And when it pushes beyond 2 degrees, that's when people often start calling it a Super El Niño. That doesn't happen very often. Since modern records began, we've only seen a handful of events reach that level. The biggest ones happened in 1982, 1991, 1997, and 2015. Every one of those years left a mark around the world. The 1982 event caught many scientists by surprise because forecasting tools weren't nearly as advanced back then. It brought severe weather across multiple continents and showed just how powerful El Niño could become. The 1991 event was also unusually strong and contributed to major climate disruptions in many regions. Then came 1997, one of the most famous El Niño events ever recorded. Floods, droughts, heat waves, and billions of dollars in damage spread across the globe. For years, it became the benchmark that every new El Niño was compared against. Then 2015 arrived. That event reached one of the highest ONI values ever observed. It was linked to record global temperatures, widespread coral bleaching, severe droughts, and major impacts on agriculture and water supplies. Millions of people felt its effects in one way or another. So why are scientists bringing up those years again? Because some of the early warning signs we're seeing in 2026 look surprisingly familiar. The Pacific has been storing an unusual amount of heat below the surface. Kelvin waves are moving that heat eastward. Westerly wind bursts have been showing up again. These are all patterns that appeared before several of those historic events. That doesn't automatically mean 2026 will become another record-breaking Super El Niño. Climate systems are incredibly complex, and no forecast is ever guaranteed. But when today's conditions start resembling the setup that came before some of the strongest El Niño events in modern history, scientists don't ignore it. That's why so many research centers are watching the Pacific so closely right now. They're not reacting to one single signal. They're looking at multiple warning signs coming together at the same time. And that's what makes this year stand out. So, how likely is a Super El Niño this time? That's the question everyone wants answered. And while no one can predict the future with complete certainty, the latest forecasts are giving scientists plenty to think about. One of the biggest voices in climate forecasting is NOAA, the U.S. National Oceanic and Atmospheric Administration. Their models show a very high chance that El Niño will develop during 2026. They also see a real possibility that it could become a very strong event before the year is over. But NOAA isn't the only group watching this. The European Center for Medium-Range Weather Forecasts, better known as ECMWF, has been running its own climate models. In some cases, those models are even more aggressive. They suggest sea surface temperatures could climb well beyond the level associated with a typical strong El Niño. Then there's the UK Met Office. Their projections point in the same general direction. They also see conditions becoming increasingly favorable for a powerful event as 2026 moves forward. When experts from different parts of the world start reaching similar conclusions, people naturally pay attention. But here's something that's easy to miss. Even with all these advanced computer models, scientists still refuse to say a Super El Niño is guaranteed. Why? Because the climate doesn't always follow the script. Forecast models are incredibly useful, but they're not crystal balls. A small change in ocean temperatures, wind patterns, or atmospheric circulation can completely change how an El Niño develops. Sometimes, forecasts overestimate its strength. Other times, they don't capture how quickly conditions can shift. One of the biggest wildcards is the behavior of the westerly wind bursts. If those winds keep feeding warm water into the eastern Pacific, El Niño could continue gaining strength. If they weaken or stop, the event may level off before reaching the highest category. That's why scientists don't focus on just one prediction. Instead, they look at a range of possible outcomes. The most optimistic scenario is a moderate El Niño that causes some regional weather changes but avoids widespread disruption. The middle scenario is a strong El Niño, bringing more intense heat waves, heavier rainfall in some regions, drought in others, and noticeable impacts on agriculture and global weather. Then there's the worst-case scenario of full-scale Super El Niño. That's the one everyone hopes doesn't happen. It could push global temperatures even higher, increase the risk of extreme weather across multiple continents, and place extra pressure on food supplies, water resources, and economies around the world. Right now, no one can honestly say which path we'll end up on. What scientists are saying is much simpler than that. The warning signs are there. The Pacific is behaving in ways we've seen before major El Niño events. The conditions are becoming more favorable, but until the atmosphere fully responds, there's still uncertainty. That's why researchers continue updating their forecasts every month. They're not trying to create fear. They're trying to understand a system that's always changing. And the more data they collect, the clearer the picture becomes. If a Super El Niño really develops, the biggest change won't be happening out in the middle of the Pacific. It'll show up in the weather we experience almost everywhere else. The first thing people would notice is the heat. Every El Niño tends to push global temperatures a little higher, but a really strong one could take that to another level. Places that are already dealing with record-breaking summers could see even longer heat waves, hotter days, and warmer nights. For many communities, it wouldn't just be uncomfortable, it could become dangerous. At the same time, other parts of the world could end up with the exact opposite problem. Some regions would get far less rain than they normally do. Long dry spells could turn into serious droughts, putting pressure on farms, reservoirs, and drinking water supplies. Crops would struggle, rivers could shrink, and wildfire season could become much worse. Then there are the places that get too much rain. A warmer atmosphere can hold more moisture, so when storms finally develop, they often release that water all at once. Instead of steady rainfall, some areas could face days of intense downpours. That increases the risk of flash flooding, landslides, and rivers overflowing in a very short time. One of the biggest reasons this happens is because El Niño changes the position of the jet stream. The jet stream acts like a giant highway in the atmosphere, helping steer storms across the planet. When it shifts, weather patterns shift with it. Areas that usually stay dry may suddenly become much wetter, while places known for regular rainfall could spend months waiting for storms that never arrive. In North America, the effects can vary depending on where you live. Parts of the southern United States and California often become wetter during El Niño years, bringing heavy rain and mountain snow. While that can help refill reservoirs, it also raises the risk of flooding, mudslides, and powerful atmospheric river events. Farther north, some areas of the Pacific Northwest may end up warmer and drier than normal, increasing the risk of drought and wildfires. Across South America, countries like Peru and Ecuador often see much heavier rainfall, sometimes leading to severe flooding and major damage to roads, homes, and infrastructure. At the same time, parts of the Amazon could face extreme heat and prolonged drought, putting one of the world's most important ecosystems under enormous stress. Then there's Australia. Historically, El Niño has often brought hotter weather and below-average rainfall to large parts of the country. That combination creates ideal conditions for drought and dangerous bushfires. Farmers can face growing pressure as water becomes harder to find and crops become more difficult to grow. The important thing to remember is that a Super El Niño doesn't create the same weather everywhere. It reshuffles the entire climate system. Some places end up with too much water, others get almost none. Some see stronger storms, while others deal with relentless heat. That's why scientists don't look at El Niño as just another weather event. They see it as a global climate shift zone that can affect millions of people in very different ways, all at the same time. A Super El Niño doesn't just change the weather. It can completely reshape ecosystems, both on land and in the ocean. Let's start with tropical storms. One of the strange things about El Niño is that it doesn't increase hurricanes everywhere. It actually shifts where they happen. In the Pacific Ocean, warmer water gives storms more energy to grow. That means countries along the eastern Pacific, including Mexico and nearby island regions, could see a higher chance of stronger tropical storms and cyclones. When ocean temperatures rise, storms have more fuel to work with. Some can strengthen much faster than expected before making landfall. The Atlantic Ocean tells a different story. During most El Niño years, stronger winds high in the atmosphere create what's called wind shear. That extra wind makes it harder for hurricanes to organize and grow. As a result, the Atlantic often experiences fewer hurricanes than usual. That's one of the few potential benefits of El Niño, although it doesn't cancel out the risks happening elsewhere. But the impacts don't stop with storms. The Amazon rainforest could come under serious pressure. Normally, the Amazon helps regulate Earth's climate by absorbing huge amounts of carbon dioxide. During a powerful El Niño, however, long periods of heat and drought can weaken the forest. Trees become stressed, wildfires become more likely, and large sections of the rainforest can struggle to recover. Scientists worry that if these dry conditions last too long, parts of the Amazon could temporarily release more carbon than they absorb. That would make an already difficult climate situation even harder. The oceans face their own challenges. One of the biggest is coral bleaching. Coral reefs survive within a very narrow temperature range. When the water stays too warm for too long, corals become stressed and expel the tiny algae that give them both their color and much of their energy. That's why reefs suddenly turn white. If temperatures don't cool down soon enough, many of those corals die. We've already seen this happen during previous major El Niño events, and scientists worry that another powerful event could trigger even more widespread bleaching. Marine life also begins to change. Warmer water can disrupt ocean currents that normally carry nutrients toward the surface. That means less food for small marine organisms, which affects fish, seabirds, seals, penguins, and many larger predators higher up the food chain. In some regions, fish populations may move to cooler waters. In others, breeding seasons can be disrupted, leaving entire ecosystems struggling to adapt. That's what makes a Super El Niño so different from an ordinary weather event. It doesn't just bring stronger storms or hotter temperatures. It changes the conditions that countless plants and animals depend on every single day. And once those natural systems are pushed too far, recovery can take years or sometimes even longer. When people hear about El Niño, they usually think about storms or extreme heat. But in reality, one of the biggest impacts often shows up somewhere much closer to home your wallets. Everything starts with food. If major farming regions are hit by drought, floods, or unpredictable weather, crops don't grow the way they're supposed to. Rice, wheat, corn, soybeans, coffee, and many other staples can all see lower yields. When supply drops but demand stays the same, prices almost always go up, and it doesn't stop there. Farmers are already dealing with higher production costs. Fertilizer has become more expensive in many parts of the world. Fuel prices remain unpredictable. If a strong El Niño disrupts harvests on top of those existing challenges, growing food becomes even more costly. Those extra costs eventually make their way to grocery stores. That means families could end up paying more for everyday items, even if they live thousands of miles away from where the weather problems actually happened. Then there's the issue of global supply chains. Today's economy is connected in ways we've never seen before. A drought in one country, flooding in another, or storm damage at a major port can slow the movement of goods across entire regions. Shipping delays, transportation problems, and reduced agricultural exports can all ripple through the global market. We've seen before how quickly one disruption can spread. What starts as a climate event in one part of the world can eventually affect supermarket shelves, manufacturing, and businesses almost everywhere else. That's also where inflation becomes part of the conversation. When food costs rise, transportation gets more expensive, and supply chains become less reliable. Prices tend to climb across many sectors, not just groceries. Households feel the pressure, businesses face higher operating costs, and governments often struggle to keep inflation under control. History shows just how expensive these events can become. Researchers have estimated that a typical El Niño can cost the global economy trillions of dollars over several years. Those losses come from damaged infrastructure, lower agricultural production, disrupted trade, disaster recovery, and slower economic growth. A Super El Niño could push those costs even higher. Of course, no one can predict the exact number ahead of time. Every event unfolds differently. But one thing is clear: the economic impact reaches far beyond the places hit by extreme weather. That's why economists pay attention to El Niño almost as closely as climate scientists do. Because this isn't only about the environment anymore. It's about food security, global trade, inflation, and the cost of everyday life. Even if someone never experiences a flood or a heat wave firsthand, they may still feel the effects every time they fill up their car or buy groceries. At this point, it's fair to ask a simple question. Is climate change actually causing all of this? The answer isn't as simple as yes or no. First, it's important to understand that El Niño isn't new. It's been part of Earth's climate system for thousands of years. Long before factories, cars, or power plants existed, the Pacific Ocean was already moving through natural cycles of El Niño, La Niña, and everything in between. So scientists aren't saying climate change created El Niño. What they're saying is that today's El Niño may be happening in a very different world than it used to. The biggest difference is the ocean itself. Our oceans are warmer than they were just a few decades ago. Year after year, they continue absorbing enormous amounts of heat. In fact, the oceans store more than 90% of the extra heat trapped by greenhouse gases. Think of it like this. Imagine you're cooking on a stove. El Niño is like turning the burner up for a while. That part is natural. But if the pot is already hot before you turn the flame higher, it's going to boil much faster. That's basically what scientists are worried about. The Pacific isn't starting from normal conditions anymore. It's starting from a much warmer baseline. That means when a natural El Niño begins adding even more heat, the overall impact can become much stronger than it would have been decades ago. We're already seeing signs of that. Ocean heat content has been reaching record levels. Global average temperatures continue to rise. Marine heat waves are lasting longer. In many places, weather records that once seemed impossible are now being broken more often. None of this proves that climate change controls every El Niño. Scientists are still studying exactly how global warming affects the ENSO cycle itself. There are still important questions that haven't been fully answered, but there's much stronger agreement on something else. A warmer planet gives extreme weather more energy to work with. When drought happens, it can become more intense. When heavy rain falls, it often falls harder. Heat waves last longer. Wildfire conditions become more favorable. In other words, the same climate event can produce much bigger consequences, because the background climate has already changed. That's why this conversation isn't really about whether El Niño is natural. It is. The real question is what happens when a completely natural climate cycle unfolds on a planet that's already warmer than it has been in modern history. And that's exactly why so many scientists are watching 2026 so closely. The concern isn't just the arrival of another El Niño. It's what that El Niño could do in a world that's already carrying far more heat than it used to. At the end of the day, there's one thing worth remembering. A Super El Niño isn't something new. Earth has gone through these powerful climate cycles before, and it will again. What's different today is the world it's happening in. Our oceans are warmer. The atmosphere holds more heat. So when a natural event like El Niño shows up, it has a much higher chance of pushing weather to the extreme. Hot places can get even hotter. Dry regions may stay dry even longer. Heavy rain can become more intense. No one knows exactly how strong the 2026 event will become. Scientists are still collecting data, updating models, and watching the Pacific very closely. But the warning signs we're seeing today are enough to make this one of the most important climate stories to follow. We'll continue keeping an eye on every new development as more information becomes available. If you found this video helpful and want clear, fact-based updates on major weather and climate events, make sure to subscribe and turn on notifications. Thanks for watching, and I'll see you in the next one.